Hello everyone. I am Loy Chao, today's lecture teacher. Today, we begin the first mission of the Project 6 Awareness of the Cockpit Environmental Control System in the Aircraft Construction course. Cockpit Environmental Control System Overview. The Cockpit Environmental Control System is crucial to ensuring flight safety and passenger comfort. Next, we will learn more about this part. This mission mainly includes two parts. One is the function of the cockpit environmental control system, and the other is the composition of the air conditioning system. We will start learning in this order. First, let's move on to part Y, functions of the cockpit environmental control system. To understand its function, we need to know the impact of the atmospheric environment on the flight and air conditioning system, as well as the impact of high-altitude flight on the human body, and then understand the core functions of the air conditioning system. The atmosphere is divided into different levels, and the characteristics of each level have different impacts on the flight and air conditioning system. The troposphere is the lowest layer of the atmosphere. The temperature decreases with altitude. The airflow disturbs violently, contains a large amount of water vapor and particles, and is prone to cloud, fog, rain, snow, and other phenomena that threaten flight safety and also affect the work of the air conditioning system. The stratosphere is located above the troposphere, with a top boundary of 50 to 55 kilometers, and the temperature of the lower stratosphere is basically unchanged. The air is thin, and the airflow is stable, which is conducive to flight, but it also poses special challenges to the air conditioning system. The International Standard Atmosphere (ISA) is formulated by international authoritative organizations based on the multi-year average conditions in the mid-latitude region, reflecting the vertical distribution of atmospheric temperature, pressure, humidity, etc. Its sea level standards are temperature 15 degrees Celsius, pressure 101325 K, density 1.225 per kilogram cubic meter, which provide a unified standard for aircraft design. The effect of high-altitude flight on the human body. As the flight altitude increases, the ambient temperature and pressure drops significantly. The main effects on the human body are hypoxia. The partial pressure of oxygen decreases due to the drop in atmospheric pressure. At 3,000 to 5,000 meters, the human body has a compensatory reaction. 5,000 to 7,000 meters, obvious dysfunction. 7,000 m above, maybe loss of consciousness. Low pressure effect. High altitude and low pressure will lead to high altitude gastrointestinal inflation and high altitude decompression sickness, etc. And the impact will be more obvious when the height is greater than 8,000 m. Influence of pressure change rate. When the environmental pressure change rate is large, people will be unwell and even serious injuries will be caused when the explosion decompresses. Changes in the atmospheric environment will directly affect flight safety and the operation of the air conditioning system. For example, differences in air pressure, temperature, and air composition at different altitudes will bring different workloads to the aircraft's air conditioning system and affect the aerodynamic performance of the aircraft. This is also one of the important reasons why we need a cockpit environmental control system. Functions of the air conditioning system. The functions of the air conditioning system mainly include providing a comfortable seating environment, controlling the temperature and humidity in the cockpit at the appropriate range, avoiding the impact of extreme weather on passengers, and providing passengers and crew with a comfortable environment. Protect the health of passengers through filtration and ventilation. Exhaust dirty air, filter dust, bacteria and ozone and other harmful substances to ensure the provision of clean air and protect the health of passengers. Maintain the normal operation of the airborne equipment. Cool the electronic equipment to avoid failure due to overheating. Maintain flight safety. Adjust the cabin pressure, keep the pressure difference inside and outside the cockpit within a safe range, and prevent passenger discomfort and damage to the aircraft structure. Physical characteristics of the air conditioning system. Overview. The air conditioning system needs to adjust a number of physical characteristics of the air to meet the needs of the cockpit environment, mainly including fresh, clean, comfortable temperature, suitable humidity, and suitable pressure. 5 aspects. Let's learn more about them next. Fresh. Part CCR25 stipulates that under normal circumstances, the ventilation system should provide at least 250 g, 0.55 pounds, of fresh air per minute to each passenger. Accordingly, according to the number of people on the plane, all the air in the entire cockpit needs to be replaced every 3 to 5 minutes to meet the breathing needs of passengers. The air in the cockpit must be clean and contain no harmful gases. The air conditioning system is equipped with air filters, and some aircraft also have ozone converters to filter out ozone at high flight altitudes. Comfortable temperature. The temperature adjustment range of most civil aircraft cockpits is between 18 to 30 degrees Celsius, ensuring that passengers feel comfortable. Suitable humidity. Different treatments for humidity in different flight stages. When approaching the ground, the water vapor content of the external air is large and the temperature is high, and the cooling of the air conditioner will cause the water vapor to condense, and the water and air need to be separated to prevent the icing of components and the cockpit mist, water droplets. When flying at high altitude, the outside air is dry, and the air supply in the cockpit will also be dry, which will easily make passengers unwell. The air conditioning system needs to take measures to improve this situation. Suitable pressure. During normal flight, the cockpit pressurization system needs to keep the air pressure in the cockpit higher than the outside world to ensure the normal physiological needs and flight safety of passengers. Cabin pressure adjustment needs to find a balance between passenger comfort and aircraft structural design. Passenger comfort needs cockpit pressure close to standard atmospheric pressure, but this will make the aircraft structure withstand a large pressure difference, and the aircraft structure cannot withstand an excessive pressure difference. For the aircraft structure, the best state is that the cockpit is not pressurized at all. The internal and external pressures are consistent, but this cannot meet the physiological needs of passengers. Regulations. CCAR25 stipulates that when operating normally, the maximum use altitude of the aircraft shall not exceed 2,438 meters, 8,000 feet, and the cockpit altitude of some advanced aircraft shall only be 1,829 meters, 6,000 feet when cruising. The cockpit pressure altitude. Cockpit altitude here refers to the altitude value of the standard atmospheric pressure corresponding to the absolute pressure of the air in the cockpit. After understanding the functions of the cockpit environmental control system, let's learn the second part, the composition of the air conditioning system. A complete air conditioning system consists of multiple subsystems that work together to achieve various functions. The main components of the air conditioning system include refrigeration system, providing refrigeration functions for the aircraft, which is a key part of regulating the temperature of the cockpit. Temperature control system, responsible for accurately adjusting the temperature in the cockpit so that it remains within the comfort of the 18 to 30 degrees Celsius. Cockpit air distribution system, reasonably distribute the treated air to each area of the cockpit to ensure that the temperature in different areas is uniform, such as cabin division temperature adjustment. Ventilation and heating system, realize ventilation of the cockpit, exhaust dirty air, and provide heat for the cockpit when necessary. Equipment cooling system, provides cooling for electronic equipment, etc., ensuring that it operates in a normal temperature environment. Cockpit pressurization, keep the air pressure in the cockpit greater than the outside world during normal flight, and meet the relevant regulations of CCAR25. The working principle of air conditioning components. Modern civil aviation twin-engine aircraft generally have two sets of air conditioning components on the left and right. The working principle is as follows. Two component valves, flow control valves, respectively, control the air supply of the two components, and the air entering the air conditioning system first pass through the component valve. After the air is cooled and dehumidified by two or more identical refrigeration components, it is mixed with hot air from the air source system to form a temperature-regulated air supply to the cockpit. The air conditioning system also provides air for cockpit panels, electronic equipment cooling, and cargo compartment heating. After the air conditioner enters the cockpit, the temperature adjustment and pressurization are completed. The exhaust from the cockpit is exhausted from the outside of the machine through the exhaust valve, and the pressure of the cockpit is controlled by adjusting the opening of the exhaust valve. The above is the whole content of this overview of the cockpit environmental control system. Through learning, we learned about the functions of the cockpit environmental control system and the composition of the air conditioning system, which laid the foundation for our subsequent in-depth study of relevant knowledge. Thank you all for watching. We will see you next time in class. Now comes the exercise session. Students can press the pause button to think and answer. Let's start now. Have all the students answered correctly?